You are welcome to Taxonomy Online Mathematics. We have a question on differentiation from the first principle. So we have the function of f of x, which is going to be x plus 2 all squared. Alright, we can recall from the formula that if you are asked to find, it is going to be the limit of as h approaches what? 0. So we need to find the expression for this. We need to also find the expression for this. So we can start by saying that this is the function. So we can have for f of x to be x plus 2 all squared. That is the f of x. You can see that if I have f of x equals to x, and I'm giving f of x plus 1, it means that this is the f of x that gave me this. So it's going to be x plus 1. So the same way, if I have f of x equals to this, then the f of x plus h will just be the addition of what? H. So we are just going to add h to the x before we square. So if I expand this, the easiest way is to expand this binomial. We know we square the first twice their product. The product of this is going to be 2x. Twice of that will give us 4x. Then you square the last. Now, so if you have the expression for the function of f of x, then the x plus h function is going to be wherever I see x, I increase with x plus h. Wherever I see x, I increase that before, or I replace that before x plus h. So this is just going to be x plus h as x squared plus 4x, which is now replaced before x plus h. Then 4 will be added. We can also do it in the sense that this is going to be x plus h plus 2 all squared. Then if you expand, you arrive at this. So we can also expand this so that we can get a simplified version of this. So this is going to be, squaring the first will be x squared, twice their product will be 2xh, then square the last will be 2h squared. Then from here we multiply by expanding. So this is going to be 4x plus 4h plus 4. So the expansion will look something like this. So we look through and see if we have common term or like terms: x squared, xh, x, h, h squared, h. I think there is no common term here. So it means that from the formula, wherever I see f, x plus h, I slot in the whole of this. Then minus wherever I see this, I put in the whole of this. Then divided by the h. So this, our function derivative of this, is just going to be the limit as h approaches 0. The whole of this is going to be x squared minus into bracket. So you don't have space there. So I'm bringing that aspect down. So that minus is going to be the whole of this, x squared, 4x plus 4, bracket close, all this divided by what? H. So now we are going to check this is a bracket. There is a minus in front of a bracket. So if you have a minus sign in front of a bracket, that simply means there's a minus 1 here. That minus 1 will multiply each of the term in the bracket. So if that is done, then we are going to have if I multiply everything in the bracket, our derivative is going to be the limit as h approaches 0. We are still going to have our x squared 2xh plus h 4x 4h plus 4. Then we have our minus, which is affecting this, so that will become minus x squared. Minus times this will give us minus 4x. Then times this become minus 4. All this over our h. So if you write this on one line, you will see that it's going to be x squared. If you are grouping like terms, it will be x squared minus x squared. So it means this and this will cancel. Another like term we are having here is 4x. We group them together, it becomes 4x minus 4x. That will also cancel out. Another like term will be 4 minus 4. So that will also cancel. So in all, you'll be left with only the limit as h approaches 0. The numerator become 2xh plus h. Now our h is squared, so h squared, then plus 4h all over h. This h is squared because from here we have the 2xh plus h squared. So the h will be squared out there. If I want to rewrite this so that h will be here, the square will be there. Alright. So if you look at this, you can see that there is a common term, h. We can also factorize the h out. So in this case, I'll have the limit as h still approach 0. If I take away the h out, the factor it will multiply will be 2x. Plus the factor that multiply this will be h. Plus another factor multiplying this will give me this will be what? 4 all over h. So you can see clearly that there is another common term. Numerator have h, then the denominator also have h. So what do we do from here? We have to cancel them out. So this will cancel this. So our limit is just going to be 2x plus h plus 4 as h approaches what? 0. So we can say that if h approaches 0, wherever I see h in the whole expression, I put in 0. So it's going to be 2x plus h0 plus 4. And that will just give us 2x plus 4. So therefore, the whole differentiation is just going to be 2x plus what? 4. So if you're asked to differentiate anything x plus 2 or square, if you expand, we said earlier on that it will be square the first, twice their product, which will be twice this, will be 2x times 2. So let me take it as 4x. Then you square the last to be what? 4. If you are going to perform differentiation of sum, it means you differentiate this, bringing the exponent to multiply. It will give you 2x squared minus 1, and that will give us 1. Then here is going to be, if we differentiate this, the whole of this becomes a constant, because the power is 1. Multiplying 4 will still give us 4. Then 1 minus 1 will be 0, so we just get 4. If we differentiate the constant, you get 0. So you can see that differentiation for the first principle give us the same answer. So that's how we perform that differentiation. Alright, if you like this video, then subscribe to my channel, Taxonomy Online Mathematics. Thank you very much. God bless you.